In this video, we're going to discuss the different types of graphs that we can use to represent data visually and then use a particular method to construct a visual data graph. So one of the most popular methods that we use to visualize data graphically is using bar graphs. Now this is where we find some type of nominal characteristic, we find the frequencies of it, and we use a bar to represent it. You should notice that this looks very similar to a histogram. The only difference here is that in a bar graph, the bars are not connected, whereas a histogram, the bars will be connected to each other. Branching off from that, we have what we call a Pareto graph, which looks very similar to a histogram, and all the steps that we use to come up with the Pareto chart is what we would use for a histogram. However, we've reorganized these bars based on the highest frequency all the way down to the lowest frequency. Then we have the time series graph, which goes with its name, is that we're just plotting data over a given time gap. We have the pie chart, where we take our data and we represent them by percentages that will take up a particular piece of the circle. And then finally we have the dot plot, which looks just like a bar graph, that we use dots to represent the numbers on the number line. Well, the one that we're going to look at today is called the stem and leaf plot. What a stem and leaf plot is a data plot that uses part of a data value, what we call the stem, and the other part of the data value as the leaf to form a group or a class. So what are some of the steps that we can use to create a stem and leaf plot? We're going to go through three of them, and what you'll find out is that we'll almost do all three of those interchangeably together. The first one is we want to take our data and we want to arrange it in order. So we want to go from the smallest data point up to the largest one. The second step is to separate that data according to the first digit. And the third step, create a display using the leading digit as the stem and the trailing digit as the leaf. So here, let's look at an example, and I'll show you how these steps kind of go together and hand in hand. Our example, an outpatient testing center. We have the number of cardiograms performed each day for 20 days. And here is the data. 20 different data points. Now they're all out of order. So first thing we need to do is arrange all these from the smallest to the largest, but I'm also going to do step 2 at the same time, is I'm going to look at the groups as this. So what are all the numbers that are ones? What are all the ones digits? Then let's group all the 10s together, all the 20s, the 30s, the 40s, and the 50s. As you do that, that will knock out step 1 and 2 at the same time. So the ones, all we have is just 2. The 10s that we have are 13 and 14. The 20s are 20, 23, and 25. 30s, 31. There are 4 32s, a 33 and a 36. 40s, we have 43, 2 44s, and a 45. And in the 50s, we have 51, 52, and 57. Now what we do with this is we're going to take all of the digits from what we're going to call our stems. So we're going to look at 1, 2, 3, 4, and 5. Those are going to be called our stems in our graph. So we'll have a vertical line. All of our stems will go over here, the leading digit of our numbers, and our trailing digits of those numbers will go on the right side of the line. So there are all of my stems, the leading digits from our numbers, and the trailing numbers are what comes after. For example, let's look at 1 here for our stem. Any number that comes after the 1 will go after, on the right side of the line here, as our leaf. So if we go for our ones digit, we only had a 2. For the 13 and the 14, we put a 3 and we put a 4. So what this means is that we have 13 as one of our 10s, and we also have 14 as one of our 10s. That's what that represents. So the same thing for the 2s. So what are our 20 numbers? We had a 20, so we're going to put a 0. We had 23, we'll put a 3 after for the leaf. And we also had 25, so a 5 goes after the leaf. If you continue out the rest of this stem and leaf plot, it will look something like this for the 30s, for the 40s, and for the 50s. What you should notice is that this is kind of like a sideways bar graph or histogram, and you can use this to make a bar graph or a histogram. Something else to notice Here's a random example of a stimuli plot. You should notice that there's no data points here. So what this means is that the data set contains no values between 20 and 29 in that range. So if there's no number for that particular stem, then there are no data points for that particular area. Alright, so what are some of the benefits of a stimuli plot? We've got 3 that we're going to look at. The first one, it's easy to determine what the max and the min values are of our data points. 2, we see where the clusters of the data occurs. Going back to our random example here, we see that there's a large cluster in the 30s, so that's what most of our data is going to be from. And then finally, the third one, we get a really good idea of how the data values are distributed. So there are other ways that you can use graphs to visually represent data and